Why do we design new material tests after big disasters? Imagine a building collapsing unexpectedly or a bridge failing during a storm. These events reveal what can go wrong when materials and structures face extreme conditions. After such disasters, engineers and scientists want to understand exactly why failure happened. They do this by designing new material tests that mimic the real world, stresses the structures endured. These tests are part of failure analysis methods that combine physical experiments with computer simulations. By recreating disaster scenarios in controlled settings, they can see how materials behave under high heat, heavy impacts, or flooding. For example, they might test how concrete cracks when exposed to fire or how steel beams bend during high winds. These tests often involve full-scale models or specific components like beams, panels, or joints. The goal is to find out what weaknesses allowed the failure to occur. This knowledge helps update building codes and safety standards, making future structures stronger and more resilient. It also guides manufacturers to develop better materials that resist damage from disasters. The data collected from these tests feeds into simulation tools that predict how new designs will perform in similar situations. This allows engineers to tweak their plans before construction begins, saving time and money. After a flood, for instance, materials used in rebuilding can be tested for water resistance and strength retention. Fire tests can show how long a building can withstand flames before structural failure. Impact tests simulate hurricane force winds or debris strikes, helping to improve design details. All these efforts aim to prevent future tragedies by learning from past failures. In short, designing new material tests after big disasters is about understanding failure better, improving safety standards, and creating stronger, more durable structures that can face the next challenge head-on.